Hey, I hope chemistry paper 2 went well, but you've not even touched physics paper 2 yet. But don't worry, no one has. So I'm going to get you started. This is everything you'll need to know about the forces and elasticity topic and practical. We'll start with this. This is Hooke's law. F equals KE. Or in a sentence, the extension of an object is directly proportional to the force that causes it. Or in other words, if you double the force, the extension of your object will also double, provided the elastic limit is not exceeded. We'll come back to that. Notice this in the middle, K, that is the spring constant. In simple terms, the spring constant is kind of the stiffness of your object. It's measured in newtons per meter. So in words, it's how much force is required for every meter of extension. Bigger spring constant means less stretchy object. Next, on to the practical. The practical is investigating Hooke's law. We're investigating how changing the force on an object affects its extension. So nice and simply, your apparatus should look like this. We need a clamp stand, boss and clamp to hang our spring from. We then add masses to the spring. Those masses act as our force. The force in this case being the weight of those masses. Also a meter ruler beside it to measure the extension. So if you've managed to set that up, it's really simple. You simply add masses, and every time you add a mass, measure the extension. Remembering that the extension is the change in length, so your end length minus the starting length. Every 100 gram mass you add is equivalent to 1 Newton of force. Just about. So continually add masses, measuring extension to test a range of forces. Couple of considerations for this practical. Safety is rather commonly examined. It would be very wise to wear goggles since we're using springs which could ping into your eyes. Also, since this involves adding masses, make sure those masses are not hung over your feet to keep your toes well away. It would also be extremely wise to use the G-clamp to clamp that clamp stand onto the table so it can't fall over. Also, just to mention, a common source of error with this might be parallax error. That sort of error will come from reading the extension of your ruler not at the correct eye level, so either being above or below. It will make the extension appear larger or smaller than it actually is. So really important to ensure that you measure your extension at eye level. With that, you can go and plot a graph of force against extension. It should look something like this. Hopefully what you'll observe is a directly proportional relationship, a straight line passing through the origin. That straight line through the origin would support Hooke's law, stating the extension of an object is directly proportional to the force that causes it. However, you could observe the line starts to curve. If that's happened, it means we've passed the limit of proportionality, otherwise known as the elastic limit. When you stretch or squash objects, otherwise known as deformation, you can do so either elastically or inelastically. If your object is deformed elastically, when the force is removed, it will return to its original shape. However, if you deform your object inelastically, that means when the force is removed, it does not return to its original shape. And it's that inelastic deformation that produces that curve on our graph. And that is all you need. We've smashed it out of the park. If that was helpful,